All right. Hi. I hope you can hear me. So we on with it. We attempting to see if we can finalize exercise number 13. Okay.
How are you, Dr. Lighton? You sound low.
I'm fine. I'm fine. Thank you for your concern. I'm alive. It's alive. Okay. Thank you for your concern. It was one of those tiring days, right? But we must continue. We are so behind with this course, right? So we have to continue. Okay. So we can't quite remember where we left off from, but we were at a stage where we were right about to start just glossing over some or the different types of storage mediums, the categories of different storage mediums that are available out there. It turns out that these different storage mediums, right? So irrespective of whether you're talking about so-called tips, so things like thumb drives, right? So-called flash disks, or what we call external hard disk or hard drives, they can all be clustered into three broad categories, right? So you have what's called magnetic storage, right?
So we can't see your slides, Dr. Lighton.
Oh, okay. Sorry about that. Thank you. Thank you very much for that. I thought I'd shared my screen. So we have what's called magnetic storage. There's also optical storage, right? And then finally, there's so-called flash storage, right? Now, you know these different instances. Most of these are widely used. Most of these widely used storage mediums here will fall into either one of those three categories, right? So you soon see that things like DVDs and CDs will typically fall under optical storage, right? Your so-called flash disks, as the name suggests, will fall under flash storage. And then things like most of these external hard drives or hard disks that you typically have access to fall under so-called magnetic storage. Now, it's usually not that intuitive for you to tell, let's say, a magnetic storage device from a flash device or flash disk, right? Usually, the easiest way of telling these two things apart is once you connect, or you can obviously open it up and then you'll be able to tell whether the device itself or the medium falls under magnetic or flash storage, right? But the other way of telling the two apart is that usually so-called magnetic storage is typically mechanical in nature. So you typically hear a sound as you are trying to access data on that particular storage device. Of course, there's also aspects to do with speed, but we'll walk through all of these different things one after the other. Right, so now I'm not really sure about magnetic storage being one of the most widely used storage devices here. I guess we've got into a stage where perhaps one would argue that flash storage is probably one of the most widely used, right? Because things like SD card, micro SD cards, so-called flash disks or flash drives, thumb drives, these all fall under flash storage. Now, this used to be the case maybe a couple of years ago. I'm starting to say I'm not really sure if we can still say magnetic disk storage is one of the most widely or commonly used types. Perhaps that's the case, perhaps not, right? But let's work with this. Let's just say this is one of the most widely or commonly used types of secondary storage. And this is it here. This is what I was talking about, where when you open it up, you typically be able to see, to be able to tell it or to distinguish it from flash storage. Now, for certain types of magnetic storage mediums, like flash disks, for instance, or tapes, it will be a bit misleading because typically the drive itself, the device itself is not embedded together with the disk or the medium, right? If you were to which was an example of, I guess, a computer system that had a so-called floppy drive, right? You'd be able to see that this, in fact, what you're seeing on top here is in fact it's a medium that would need to be, so what I mean is this thing here on top would need to be slotted into a drive, right, or a device that will be able to read data from this medium. The case is different for what you're seeing below here, because it turns out that the storage medium, right, which is this part here, is embedded together with the drive, right? So just take note. It's the same as I guess it's the same as this medium here, right? The small little thing here. I don't know if you can see this here. Micro SD card, right? You typically need well, typically your computer or your laptop will have a drive which you use to slot this in. Now, in my case, most of the laptops that I have access to will require an adapter, because it turns out that I don't have a provision on my computers where I can just slot in this card here. So I typically need to first of all slot it into this adapter here, so that then I can plug it in or insert it into the drive that I have, right? So this thing here, the adapter is what I need. And this makes sense because it turns out that this thing here can be accessed using different types of computer systems. I mean, so if you have an embedded computer system like a digital camera, for instance, you could typically slot this in. I know my GoPro takes in this thing, right? The micro SD card without any adapter, right? So the things to take into account. If you have one of those funny phones, well, funny because these days it's not the case, right? Funny phones which enables you to extend the storage of the storage, right? Secondary storage on your phone, on your mobile device. I do believe you can slot in the micro SD card the way it is. You don't need an adapter. At least the previous phones that I've owned, where I was able to extend storage, used to work that way. So the idea behind this, the way the technology works really, is that you have the data being magnetized on spots on the disk itself. And so the best way of, I guess maybe this will make a lot more sense once we look at data encoding. The best way of thinking about how data is stored here is trying to imagine exactly how you would want to represent these ones and zeros, right? Think of the data as being nothing more than a combination of various ones and zeros, right? So in the case of magnetic disks, what you have is the data is represented in terms of magnetized spots on the disk itself. So you'd represent the data in such a way that a bit of data would be represented by 1, and then if there is data, right, you represent it with the 1, and then if there's no data, you represent it with a 0 bit or something. Now, it's usually the case that these magnetic disks will typically be composed of so-called tracks, right? Now, it is on these tracks that you have data being written to or read from, right? So typically, so something like what you're seeing here will have information being stored. I guess we can visually represent it like the way I'm representing it here. Right, and then you have this sort of like head here that will, as the disk is rotating, this head is used to access data located at a particular point or location along these different tracks here, right? Which is why when you're accessing your external hard drive, right, you typically hear some funny sound. Ideally, what's happening here is this mechanical device is trying to go to the spot where the data you want to access is located, right? So again, the classic examples here, things that you've probably used, are things like so-called hard disks or hard drives, right? This thing that you have at the bottom here, floppy disks, these are no longer used. What you're seeing on top here, tapes, right? Magnetic tapes. The magnetic tapes would be similar to what I showcased last week? Right? I don't have an example because it turns out that I wish we could, if we're on campus, maybe we're going to go to CICT, right? We go to their server room and then ask if they can give us access to show us examples of the tape. I'm sure they do backup stuff to tape, right? Let's see, tape. Let's see if we can find an example of how tape drives look like. So they come in various shapes. I remember when in my previous life, when I was working in the telecom sector, we used to use a lot of smaller version, right? So it's smaller tapes, but high capacity tapes. This would be tapes that, if my memory serves me right, some of them were up to, I think, 50 terabytes or something of data, right? So if not more, actually. And if you think that that's a lot of data, you're mistaken, right? Because I remember some of the computer systems, several computer systems we used to work with, would be used to power so-called databases that were partitioned into days, right? So we typically partition the databases into days because it was much faster to access data that way. And a day, or depending on the type of CDRs that you're working with, anyway, at least in our case, CDRs would occupy anywhere between maybe 2 terabytes, about 2 terabytes or something, right? So if you think about it from that perspective, you realize that this one tape here is not sufficient, right? So typically, maybe to back up a day, for instance, a day's worth of data, you would need one of these. And that's what I'm trying to say here. Which is why it makes more sense that if you're thinking of if you handle significant amounts of data, you are better off going for a storage medium that is much cheaper because it's much more cost effective that way. All right, so I don't know if I'm making sense here. Imagine a situation where you're backing up, let's say, an average of about 50, maybe 100 terabytes of data on a daily basis. So you're faced with a situation where you have to decide on whether you're going to use, whether you're going to back up this data onto optical storage, like DVDs or something. There are high capacity DVDs these days, by the way, right? Or whether you're going to use tape, or maybe you want to invest money into a cluster that will enable you to back up data to something like this, but high capacity hard drive. You have to think of it from the perspective of how much it would cost you, how much money it will cost you. Turns out it's much cheaper to go with much slower storage mediums like tape. And usually the pattern is such that the slower the medium, the cheaper it is. Currently, I do believe tape should be the most cheapest, I guess. Anyway, I don't know. So always think about these things from the perspective of cost, right? And this is the thing here. If you look at all these different aspects that we've discussed before in the past, when you're making a decision on what exactly you're going to go for, you're sacrificing one feature over the other, right? So if you're obsessing a lot about cost, if you're this company that is that operates on a string shoe budget, for instance, maybe an SME or something, you sit there and you're thinking, should we really go for speed or cost? Well, speed is important, but we don't have money, so we'll go for the cheapest, right? If you're a company that makes reasonable amount of money, like banks, for instance, right? And you know that the data is extremely important, then you know that probably it would be wise for you to invest slightly more money, irrespective of how much more it's going to cost you. Why? Because perhaps you are obliged through legal obligations to adhere to certain standards. Like I do believe the banking sector, I don't know how many of you have checked here. If you have an online banking account, what you notice is that I think you can go back, is it 180 days or something? I could be wrong here, but you can go, at least in one of my banks, you can go back 180 days. So you can retrieve your transactions you've performed in the last 180 days. That's about 3 months. But it's entirely possible that they're obliged legally to be able to provide transactions on demand, let's say going back maybe 5 years or 10 years, right? That's happened, right? there are these fraud cases that will pop up every now and then. I don't know how many of you are following through with the financial trends report that was recently circulated, right? So these are things to think about here. In certain instances, irrespective of whether you have the money, you'll probably be forced to invest in a certain type of storage, right? Because of certain requirements that you might have, right? Great, so there's optical storage, right? And the idea behind optical storage here is you typically have, you use laser technology to actually write the data onto the medium itself. Right, so your DVD drive, the so-called DVD drive, back in the day, I remember we used to obsess a lot about whether you had a DVD writer or something, right? It was a premium. And these days, your average computer system that you buy that has a DVD drive will probably be able to write data to the disk itself. But alas, I mean, a couple of years back, maybe a decade or so back, it was an expensive commodity. And so what you typically have is just have a DVD or a CD reader, right? You could only read data that had already been written to, right? But the idea behind storing data onto optical storage is you use laser technology essentially, right? So as you are burning, we used to call it, I don't know if you guys still call it burning, right? As you are burning data to CD, you need a special type of application software. Turns out that I do have this special, I don't know why I even have this, I'm sure it comes by default with this thing here. I have, this is called K3B, disk burner, right? Disk burning. So you obviously select the data on your computer system, and then I could have done a demonstration here if I'd known. Maybe we'll do that. You slot in a blank, right? Blank DVD or CD, assuming that it's not a rewritable optical storage, because it turns out that in certain instances, some variations of this optical storage are not rewritable, meaning that data can only be written onto them once. And these are the cheaper variations. So once you write data to the optical storage, that's it, right? If you make a mistake, you throw it away, you have to use a different optical storage device or medium. Right, so you use special type of software, obviously, and the software will interact with the either the CD writer or DVD writer to enable you write the data onto the device itself. And it turns out that in terms of the way data is stored here, it's more or less similar to magnetic storage, where data is stored on tracks, right? So as you're burning the data, it's stored on tracks. And in fact, what would typically happen is, again, you'd be able to hear the same type of noise as you're accessing data on a DVD or a CD, right? Because you're trying to, you're using your drive as, it's not like explicitly using your drive to access this data, really. You'd probably access the data using, not probably, you'd be accessing the data using a file manager, right? But as you're maybe double clicking to gain access to the data, you found the data, you hear some funny sound, right? Because it turns out that you're trying to go to the specific location on this storage medium where the data is located. Right? And then there's a more modern variation, so-called flash disk storage, right? Which is implemented using flash technology. And the idea behind this is you're essentially just using integrated circuits, right? Which makes it much faster. One of the reasons it's much faster is because you can access data at random. So you're no longer faced with a situation where you have to sequentially seek to go to the location on that particular medium where data is stored. You can randomly access the data that way, just like you do with RAM, right? Which is why it's expensive. I mean, sorry, this is why it's much faster. It also requires less power, obviously, because there are less moving parts, right? Compare something which makes use of integrated circuitry with something which has different mechanical components here. You need a lot of power for this thing to move around. I don't think there's a, let me see here. Don't think there's any magnetic storage device I can think of that would operate without physically plugging it into a power supply or something. Could be wrong here. But this makes sense. This explains why those thumb drives that you have, right? You just plug and play. Just pick it up, right? this thing here, pick it up, you plug it into a computer, and then you can use it without having to worry about it. Right? This thing here, this part here, these two things, the one labeled ETD 2011 and the red thing here, number 6 and number 7. It's not the case for this thing, for things like this Toshiba thing. In fact, with this, I need to connect it to my mains power supply for me to be able to access data onto it. That's how horrible this is, right? If I don't have power, I won't be able to use this thing. Of course, the much more modern variations like this transcend, for instance, all I need to do is just plug it into a USB port, and then it takes advantage of power coming from my computer system. Right. And then in terms of the way that you typically connect storage to your computer system, it turns out that there's different ways of doing this, right? So 2 main ways, actually. You have what's called direct attached storage and network attached storage. And the names are pretty much self-explanatory. I do apologize for the noise. I don't know if you're still there, but I'm sorry about the noise. It's so sad sometimes, some of these places where people leave, right? Anyway, can you still hear me?
Yes, sir.
Yes, sir. Yes, sir.
Yeah, sorry about the noise in the background. Very unruly kids. I don't know how kids are brought up these days. Anyways, so there's direct attached storage and network attached storage. And so the idea is the names are pretty much self-explanatory. For direct attached storage, these are storage mediums, devices that you directly connect to your computer system. And then you also have what's called network attached storage. And we'll go through these in sequence, right? Network attached storage, which typically gain access to via network, right? Another variation of network attached storage would be like a storage area network, which would be like a dedicated computer network, which is solely composed of storage devices. I don't know if you've got into a stage in 1020, please pay attention to 1020 when you start discussing. I hope you were paying attention. If you weren't, please review what you discussed when you started looking at computer networks and the internet. It might help you understand some of these things we're going to be talking about, although, I mean, it's not that hard to understand anyway. Have you looked at local area networks, wide area networks, metropolitan networks, metropolitan area networks, and the internet or something?
Not yet.
Okay, that's fine. It turns out that a network is nothing more than an interconnection of various computer systems, right? This is how we communicate. So right now, Lighton, together with you guys, are connected onto some network, right? Probably the largest of all networks that we know of so far, unless if there's some secret large network out there, which is called the internet, right? In certain instances, if you work for, let's say, a medium to large organization, you would have a dedicated local area network. If it's a small organization, a local area network will do, right? Like UNZA, for instance. When you're on main campus, everybody is connected together. By everybody, I mean all the network nodes, the computers, and the various other types of network elements. And we discuss this in 1020 once you look at computer networks and the internet. They're connected together in what's called a local area network, right? So it's a smaller geographic location, like campus. If you're a small to medium type business, maybe you work in a one-story building or something, or one room, it would still be a local area network. Typically, that sort of local area network would involve you physically connecting the machines, right? Via those, I don't know if you've seen those ports, right? The Ethernet ports in these rooms, the classrooms, right? You need a cable, like a lecturer comes in, sometimes they'll connect a cable or something. It's called an Ethernet cable. They're hooking up direct to the local area network. Of course, things have changed now, right? So you can also hook up your computer to the local area network via Wi-Fi, which is what we do when we connect using EduRoam on campus, right? So anyways, network attached storage and storage area networks will involve you accessing storage via an existing network, an interconnection of computers. Right, so in terms of direct attached storage here, if we can latch on to some of the things we just spoke about here, this would be you connecting these things that I just introduced a while back. So if I can go by, I'm sorry for context switching here, but this would be you connecting things like this direct to your computer, right? So like the way Lighton does on this, for me to connect most of these things here, like for 1, 2, 3, and 4, but 1, 2, 3, 4, 7, and 6, I just take advantage of my USB ports, right, to connect them directly to my computer systems, right, my laptops. For optical storage, like 5, all I have to do is I'm directly connecting to it, I guess, by just slotting in this optical storage device, storage medium here into optical storage drive. Right, so my DVD drive, I have a DVD drive. But just as well, this DVD drive that is integrated with my computer system could just as well have been an external CD or DVD drive. It's possible, in which case I'll probably hook it up to my computer system using a USB port as well, right? So direct attached storage. Oh, sorry for that. Should have put it on silent. I do apologize for that. Right? Right. So you're directly attaching these components to your to your computer system. And again, let's not forget what we discussed when we were looking at input-output devices, right? So that applies. Yes, sir.
How true is it that SSDs, solid-state drives or disks, are stronger or more durable than magnetic disks? Hard drives.
Not quite. I mean, you want to, this way of doing that is, I don't have the actual numbers here, but if you look up the lifespans, you notice that the lifespan of SSDs is much, much less, right? So if you're looking at durability from that perspective, then one would argue that they're not as durable, right? But again, you don't want to lump, if you're doing a comparison between something like optical storage and magnetic storage, there's different variations of magnetic storage, right? Just mentioned here that you have tapes, you have zip disks, you have floppy disks.
So I'm talking about magnetic storage, the external hard drive, because when you drop it, it is in rare occasions that it works again after you drop it, compared to SSDs.
No, that's not true. What do you mean? I don't.
Like,
I don't know about that. I mean, I don't know about that. I don't know about dropping it. I mean, one argument would be that because your hard disks, you're talking about hard disk and SSDs, has a lot of moving parts, then obviously it's more prone to get damaged, right, easily when compared to SSD, right? Because an SSD is simply made up of integrated circuitry. So, I mean, I don't know about how you're defining durability here, right?
Yes, yeah, your explanation was just okay.
Yeah.
The fact that there's more movable parts as compared to integrated chips with an SSD.
Yeah, I suppose. Yeah, I mean, so these are you raised a number of important things here, right? Things like maybe that's something else you'd have to take into account. I mean, if you're one of those characters who moves around a lot, maybe you have a girlfriend or something in the new race and you move around with your hard disk for whatever reason, if you know that it's going to get damaged, then maybe you should invest more money by buying something that is less likely to get damaged or something, right? So crazy example here, but I just thought put it out there, right? Moving parts. I just made an educated guess about the moving parts thing, right? It makes logical sense anyways. But I was thinking of, and I guess I shouldn't really think of what I was thinking about as being durability here. I guess what I was thinking about was longevity, right? So how long because remember, data that you're storing on these things will not last forever. So the data that I have here, by the way, and I guess I've been too lazy. I have data here that dates back to, let's see, 2008, right? It's about 12 years ago. It's still here. Of course, I've had this since 2000 and the data is old, quite right, but I've had this Toshiba, I think, since 2009, if not 2010 or something. So I should already, in fact, I've already done this. I should already start thinking of migrating the data that is here, because it turns out that at some point I'll be unable to access the data here, right? And we talk about backing up, the importance of backing up data, replicating data just now. Maybe all of this should make sense. Great question. And then obviously you have what we're calling as network attached storage, right? And the idea here is you're accessing storage via an existing computer network. This computer network could either be a local area network, a wide area network, it could be a metropolitan area network, it could be a wide area network. But the idea is the same, right? Because you're accessing storage via network, you need a network interface card, the NIC here, right? Now, the NIC could just be there to facilitate you getting access to the network here. Anyway. So the same idea holds for storage area networks. And in fact, network attached storage area network is just a variation of network attached storage. The difference is in that with the storage area network, what you have is a dedicated computer network. So it's an interconnection of computer systems whose sole purpose is to provide dedicated storage mediums, right? And I think we have this at Zambia. If we don't, I'll be very worried. The reason why you want to isolate a storage area network from the main network is you want it to be as fast as possible. I don't know if you've noticed that you probably have peak times at UNZA, right? When you're accessing the UNZA network, you'd be surprised. Why is the network so slow? Like, I guess if it's in the evening when everybody is on Facebook or something, or when a lot of people congregate on those hotspots that we have, like right outside the School of Education building and somewhere near the bridge building there. I normally see students congregate there. You typically notice that the network is going to slow down. It slows down because it's congested. And the same applies for these networks that you use, like mobile service provider networks. Like if you're on MTN, MTN has what's called peak hours and off-peak hours, right? Which is why they try to discourage, we try to sort of like distribute the load by making it cheaper for you to access the network during off-peak time. Have you not noticed that you have those funny packages where you can access them late at night, right? They're so cheap. They're trying to force people like you who don't have jobs to access the internet when busy people that have jobs that are doing the important things, I guess, if you can call them that, to be able to access the network, right? So you are forced to access the network late at night. We don't know what you do at night. And then the people that work will be able to access the network during peak time, I guess, because they have the money, right? So that way you're distributing the load. If you're not doing that, you have a much slower network, right? One way of trying to come up with a viable solution to prevent access to data being slowed down is to have a dedicated network, a storage area network, which is just going to be composed of computers that provide storage capabilities. It's like any other network, except it's isolated from the main network so that it's much faster, right? Anyway, and usually these days, these things are typically wired to the network using fiber, which is the fastest medium so far, right? Faster than copper. Last time I checked, so the clusters that we have on main campus, on Great East Road campus, were connected using copper wires. So we were connecting to people at VET, for instance, using copper wires. I'm not sure if they've upgraded now. I think they should have upgraded. I mean, there's crazy things happening in the country. I'm not sure. Oh, I was going to say if you discuss this in EDU 1020, but I don't know if people have heard of Fibercom, right? Some of you, hopefully, very soon are going to be working with Fibercom. Fibercom is a subsidiary of ZESCO. Great things happening in the Republic. There's fiber being laid down all over. The country is being interconnected, right? Which is why when you are on the UNZA network, you can easily connect to someone who is at CB or something, right? Because it turns out that, I don't know if you've seen a thing called Zamren. So this is ZESCO Fibercom. There's fiber being laid out. Ignore the thing, this map here, it's odd. I'm sure they've made tremendous progress here. If you look at the years down here, this key here, this legend, you notice that pretty much most of the country is connected now. We've gone full digital here, right? This is interesting, right? It's interesting because I guess from part of government, I guess most of these government departments, or whatever it is they call them, are probably interconnected with each other. But if you look at the higher education sector or the education sector, it's even better for us because we have so-called NRENs, right? No, why we're talking about networking now, but we have so-called NRENs, and the idea behind NRENs is you're interconnecting all the education institutions around they're interconnected education institutions around the country, right? You can easily, I wish there was a nice map here. Oh, there we go, it's here, right? You map. Oh, wow. I didn't know they've changed their website. I haven't accessed it since I don't know when. But you can now you can connect with somebody from CBU easily using eduroam. How cool is that, right? I think it's nice, but that's just me anyway. I don't know what you think, but I don't know. Please think about this. Once I'm sharing, part of the reason I'm sharing this is when you start your discussion of computer networks and the internet, cool stuff there in 1020. You want to be able to, if Mr. Mwalimu will not talk about these things, you want to be able to ask him questions about this so that he can explain further about this. Granted, there is a dedicated course, is it at fourth year? Data and communications networks. It's dedicated to studying computer networks, how these work, how data is transmitted from one device to the other, how it gets to be broken down. Pretty cool, actually, because it turns out that the data is broken down into ones and zeros, right? So ones and zeros are the ones that are being transmitted. So if I send, oh, now I'm sending the data to you, right? Surprise, surprise. So I'm speaking to my microphone. The sound is going to be broken down into ones and zeros. The ones and zeros are the ones that are being transmitted to your respective devices. Once this stream of ones and zeros get your devices, they are reassembled, right? And then you're able to listen to Lighton speak, and you think, oh, Lighton is speaking. Well, I was speaking, but it's my data converted into digital form, I guess. It's so interesting how this works, right? But I don't want to sidetrack you, right? We are still discussing storage area networks. The fundamental idea is that you have these computers that act as that provide storage capabilities being isolated onto a dedicated network, a much faster network. But the idea behind accessing storage area network is the same, really, obviously. You access it through a network, right? And then these days, right, we have so-called cloud-based storage, right? Oh, I have a Dropbox account. I do myself. Can you save the data to my G drive, right? Cloud storage. The idea is the same. If you think about it, you're accessing data via network, right? Except this time around, when you look at storage area network or SANs, you're accessing data on the same network you're on, probably a local area network or maybe a metropolitan area network or something. Or it could be like a secure wide area network or something, right? Like the case is for UNZA, so the regional offices that we have in the different provinces would typically access the same storage infrastructure via the internet, right? Wide area network. But with cloud-based storage, what you're doing is you're taking advantage of the biggest of all wide area networks, which is the internet, right? For you to access the storage, the data that's stored on these storage devices. Here's the thing here. The storage mediums that you're using are pretty much the same as the ones we've discussed, is directly attached storage, except this time around, they're directly attached to a remote computer system somewhere out there. What you're doing is you're interacting with that remote computer system to gain access to the data, right? Via the network. I hope that's clear enough. Now the question comes in here, and I'm looking at the time here. Looking at the time, 42. We can, right? I guess we can. Right. So here's the thing. This brings us to the next topic, right? The idea of backing up data, the importance of backing up data. Something that will probably enable you to gain an appreciation of why it's important to back up your data is that if you think about it, right, everything that we do on these computers, irrespective of what you use your phone for, maybe you use it to share memes or to post on Facebook or to write assignments, what you're doing is you're processing data, right? It turns out that data is the most important commodity here. These things that we use are just a means to an end, right? We are either processing data or creating new data, right? Or transmitting data. Now, I think what I'll do is, before I set the stage for a discussion with data backup, I'm going to just, I just thought of this here. I'm going to wing it now. I'll talk about a few stories here, right? And I want us to think about these stories before we start out. We continue our discussion on Friday. I think we should be able to wrap up that backup and whatnot, right? I hope I have emails that I can show as proof. You see, Lighton made up those things here, right? So a while back, right? I don't know if you remember, we had I had shared certain URLs, right? There was a list.unza.zm/tilde Lighton period, right? I don't know if you remember this. We also had list.unza.zm, right? Pierre is not teaching you. And Tambewe had his own personal homepage here, right? It turns out if you access these things right now, there's nothing there, right? There's nothing because we lost the data, gone. Like 3 years worth of data just gone, right? Now, I wish I could fish out. I don't think there's anything secretive here, but I'll just to try and see if I can tell this story from the test by showing you some of the emails here, right? I'll start with Zajlis server backup or something. So the story goes like this, right? Zajlis backup. The story goes like this. Anyway, it's not there. So when we had these things here, it turns out that what CICT decided to do, right? We requested them to set up a server for the department, and we told them that the server is going to host a number of services, and we had a lot of services here, right? Nifty application software tools like Lime Survey, for instance, for constructing online questionnaires. We had a collaborative editor called EditPad. Is it Etherpad, I think? Usually comes in handy when we are doing programming type work, right? Because you can share code in real time. But that's besides the point. So a couple of months back, we noticed that there were almost always issues with the server, right? With the services on the server. So it would be inaccessible, it would go offline. And it turns out when we requested that we be granted server space, the way CICT operates is that they have huge servers, right? With a lot of resources by way of RAM. And what they do is they create virtual machines. So they created a virtual machine for us. That virtual machine was given the domain this, right? This was the network name, I guess, right? Virtual machine. And unfortunately, it was sitting, the virtual machine itself, once created, the virtual plants was sitting on a damaged sector of the storage, which was assigned to the server, right? And so the time came for us to migrate this data because the part of that storage was damaged. It was hard for us to migrate that data, right? But we did manage to salvage some important information. So what happens? We back up that data. Now, a few weeks ago, I wish I could find that email. This is a good story here. A few weeks ago, we get an email, right? And we are told, and you can see here errors and whatnot, right? CIC tells us you have to quickly back up because there are a number of other servers that are problematic, and so we need to migrate everything to a new server. So in our quest to quickly, I hope we can, I don't know if you can understand any of this, but I was trying to see if I can reconstruct this story by salvaging some correspondence that I had, so that you gain an appreciation of this, right? And that there's takeaway points to all of this, by the way. So what I did was I foolishly, now I'm saying foolishly because there was a bit of thought given to this, but I was winging it, right? There's another server that we were given by Xamarin, right? This is where our departmental journal sits on, right? It's called Zajlis. It was almost like it was a punishment from the gods here. I don't know if you're still there here. But so what happened was I quickly, because I knew that this is it's an ultra fast server, right? Extremely fast. So what I did was I moved quickly. Within a few hours, I moved data that was important from here to this server here, right? And then obviously everything was migrated to a completely new server, and everything was wiped, right? And so sadly though, I was doing this on a Monday. I think, was that on a Monday? Yeah, on a Monday. And somebody, one of my colleagues, was working on something on the Zagli server. So they were trying to upload some articles, I think, or something from this server. And you can access this server, by the way. There's some nice publications that maybe you might want to read up. I do encourage you to go here, right? And in the process, what they did, right, is they accidentally deleted data from here. So we went back and forth. They reached out to me. Is there a way we can access data here, right? So I tell him, I told my colleague to say, we need to reach out to Xamarin because it's actually the server is more or less like the services here are managed services. So everything we don't do operation and maintenance tasks here, right? All the OM is done by Xamarin, right? They back up everything on our behalf. And so I wasn't CC'd in the communication that took place, but he reached out to them and told them that I had advised that we check to see if they had backups. Foolishly though, and I'm saying sadly, not foolishly, it's not their fault. The backups here are done weekly, right? Every Sunday. Right? And when I was backing up things here, it was on a Monday. So when they restored data that was backed up the previous Sunday, I think that was a Wednesday or something, they actually reverted to the state of the machine on a Sunday, effectively wiping clean the stuff I had done on Monday. Everything is gone now, right? It's gone. Now here's the thing. What we've done over the last 3 years, right? It's trivial stuff. I can do that again. But the problem is it's time consuming. This is stuff that will take days, right? And I don't have the time, I guess, right? It will take days to retrieve the data that is scattered around, to reinstall the applications, to... So that's one story, right? The importance of backing up data. And you will realize when you start our discussion of backups, that there are different strategies. You don't necessarily have to back up weekly. In certain instances, if the data is not very important, you can back up monthly. It is recommended though that sometimes you back up daily. Now, if you're doing daily backups or weekly backups, what you begin to realize is the amount of data that you're going to be backing up is going to be massive, right? So these are things to think about. Suffice to say that there are different backup strategies. Like you can take advantage of, as opposed to doing full backups, you can take advantage of incremental backups, or differential backups, right? So we'll look at all these different things. Another story that I have for you, I was a month into my job at Celtel back in the day. They are now called Airtel. And one of the things I used to do was I used to babysit a subscriber lifecycle change platform, right? So typically these mobile service providers will have a mechanism in place to try and check if you've been, for how long you've been active on the network. The policy way back used to be that if you've been inactive for a total of 90 days, you are useless. You don't have to be on the network because you cost money to be on the network. So they'll delete your account. I don't know how many of you have gotten email messages to say if you don't make a call, an SMS, your account will be deleted or something, right? It means you've been inactive for the last 90 days or something. Now, a month into my job, I accidentally deleted the data, subscriber lifecycle change data for that particular day. My God, I spent the whole day. I remember I didn't eat that day, right? I didn't go for lunch and people were surprised. Trying to fix the problem because I knew that I was going to be a goner, I suppose, if I told my boss to say this is what I had done. Perhaps not. I mean, I wasn't really that bad, right? I'm putting myself up there on the pedestal here. But the thing is, I was able to restore the data because there was a backup, right? Not a backup, actually, there was raw data, backup raw data. So I was able to recreate the state of the data. And I never taught them until this day. I always use this as an example to tell people the importance of backing up. Another story, right? Moodle, this thing you're calling Moodle. People lost faith in Moodle a while back because at some point when Moodle was being used, data was completely lost because the server crashed and there was no consistent backup that was available, right? I mean, we could spend the whole day here talking about the importance of backups. I have lost personal data myself. because some of the storage mediums that I've accumulated over the past, I have a lot of them, by the way, have just become inaccessible. And in my case, I especially don't have faith in this thing here, I hate number 8, just because I normally go for the cheaper variation. They'll just suddenly stop working, right? I don't know if you've experienced this in your mobile device where your micro SD card just stops working, right? Android will just refuse to access data there. So there's different use cases here. We can spend the whole day talking about this. I don't know if you guys have heard about what happened to Comesa building on fire, right? You remember that? Are you still there?
Yes, sir.
All right. Does anybody remember the Comesa Secretariat? This was back in 2011. If you can see this news item here, it caught fire. Massive amounts of data was lost here, right? Lost because people didn't take backup seriously. Now, some of you guys are going to be hired. You'll be paid good money to do nothing. Your sole purpose in life will be, I guess, part of the purpose in life will be to look after such systems, which will be good, right? They've become so sophisticated now, so sophisticated that we have platforms like Zambia National Data Center. They're now called Infratel. Now, it's unfortunate that we are now doing this online, but in the past, what we've done is we've organized trips, or students have organized their own trips to go and visit some of these locations. Like last year, we started facilitating the interaction with Infratel. They went on a tour to go and see the sort of infrastructure that they have at Infratel. Right? Infratel is, I think it's a government-owned entity or something, probably part of Smart Zambia, maybe an independent entity or something. You want to look into this. They operate similar to Dropbox and Google's, is it Google Drive or something? And so the difference is that this is a local initiative. So data that you store with Infratel is located right here in Zambia, right? Now, you might be sitting there and you're wondering, but why? Why would you do that when there's Dropbox and whatnot? Well, it turns out that there are certain restrictions for sensitive data, like certain government generated data. There are policies that dictate that it shouldn't leave the confines or the borders of the Republic of Zambia. It must be stored right here, right? I'm going to leave you with that. I'll let it marinate, and then we'll continue our discussion day after tomorrow. Unless if you have any random questions, think about this. Think about some of the scenarios that you think you've personally experienced, and we can talk about them day after tomorrow as we transition to talking about backups. Right? Again, on backups, we just gloss over some strategies that we need to take advantage of. I'm really looking forward to this because I'm hoping I can get more space from Dropbox by using my affiliate link. Any questions?
I have one, sir.
Okay. Yes, sir.
Yeah, there was a message that was sent in the mailing list by Kennedy. Yeah, he sent a photo which was suggesting that there might be maintenance taking place on the servers and how this would affect our quiz on Friday.
No, that's on. It won't. I received that as well. I looked at that. It doesn't affect us. It's on Sunday. Is it? Oh, was it Sunday or Friday? Bang.
It's Friday.
It's Friday. Crap.
Yes.
I haven't read that email, but you notice that I haven't read that. Great. Okay. Thank you for that. Okay. Looking at the gravity of the situation here. Okay. Thanks for, I haven't read Kennedy's email here. I don't know if you can see that it's unread. Let's see. Nah, I didn't respond. I haven't read it, I think. I don't know when it was sent. But I guess we'll have to move this to Monday then. I was going to be tempted to say we open it up beginning 17 hours tomorrow. But let's not rush things. I'll send out an email. Thanks for reminding me about this. It's actually Friday to Sunday. So what I will do is I have another story, right? When I used to work for previous life, the maintenance on the network was always done early in the morning. I used to hate that sometimes, right? You stay up late, you have to be in the office because maintenance, all the services are taken down when the network is not being used that much anyway. So it used to be midnight to 05. What UNZA is doing here is quite sad, right? Where everything is being done. But I guess it's just thinking weekend is fine. So I'll send out an email. We are moving the quiz to Monday, I guess. Thanks for that reminder. Otherwise, would have had people, you know, wow. How do people feel about opening the quiz at 17 on, or 16 on Thursday and closing it on Thursday on Friday? I mean, on Friday at 16. What do you think? It's a question.
In my case, I would say Monday is just okay with me.
Okay, all right. Monday, Tuesday. I know. Let's not wing it. We'll move it to Monday. We don't know what will happen. Maybe for all we know, CICT will just say, no, we're starting maintenance work early on Friday or something. So we don't want confusion. We'll move the quiz to Monday. I will send out an email. Actually, I don't want us to mess up our Monday class. So what we will do is we will move the quiz to Tuesday because we don't have class on Tuesday. I don't want to mess up the Monday class. So we'll move the quiz to Tuesday. I'll send out an email to that effect. Thank you so much for the reminder. See you day after tomorrow. Good day. Thank you.
Good day.
Good day.